Hello everyone, Nostradamus here again with Foreign Age News, just for you. Hope everybody's doing well. It's going to be a serious video covering a few various things. I'm very late starting tonight, so probably hardly anybody's going to see this video. Everybody will be fast asleep by the time I upload it, but anyway, let's get going. I'd like to start by quickly going over the latest methane figures. Now with the METOP 1B satellite has been out of action now for about 2 months. So rather than redo all my old figures, I've just been estimating what the defunct satellite's data would be. So the satellite data I'm using now, if it goes up by 3 parts per billion in 1 week, then I'll assume that the other satellite went up by 3 parts per billion also in the same week. So they're both, it's the only method I can really use to keep all my figures intact, my historical data. But because I'm averaging half as much data each week now, that me graphs are getting a bit wavier. Well, they should still be quite accurate. So here we've got the last 35 weeks. This is the lower atmosphere from 931 up to 300. No, hang on, I always get my numbers mixed up. Yeah, 931 to 300 millibars, the lower atmosphere, and this is comparing this year's, the red line, compared to the same corresponding time last year in 2020. You can see we're a good 17 or 18 parts per billion higher than we were 12 months ago at the moment, and the graph seems to be levelling off in the lower atmosphere. Here is the graph for the upper atmosphere from 477 all the way up to 151 millibars. Got the last 12 months shown here. The blue line is the averages I've been working out, and the red line is the 3-week average, which smooths it all out. And see, we're 1915, which is 25 parts per billion higher than where we were 12 months ago. Actually up to 1916.5 this week's number, and we are 40 over 40 parts per billion higher than our lowest point, which was in February of this year. Also, you may notice there is no double peak anymore. It's just gone straight up since the end of February. The rise is even more sharp, just looking at 151 millibars in particular, at the height of the atmosphere. This graph is showing going back to the 27th of June 2020, when I started collecting the data at 151 millibars. And if we look here where my mouse is, around where this little blue dip is, here, we're about 30 parts per billion higher now than where we were at this time last year. It did look as though it was coming down a touch in the past few weeks. Well, it looks like it's on its way back up again, and it shouldn't be doing that now at the beginning of November. there's no need to worry, because COP26 world leaders have pledged to cut methane emission levels by 30% by 2030 in a game-changing commitment. Well, if they stop all this blah 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 and blowing of hot air, that'll cut it by quite a few percent. I'm now going to cover quite a bit about La Palma and the volcano. Now, every man and his dog is covering this volcano at the moment, and I'll try and bring something to you that you may not have seen before. You may have seen all of it, or bits of it, or none of it. Anyway, if you've not seen any of it, I hope you find it interesting. This is from the Hal Turner radio show on the 31st of October. Update, 8:47 p.m. La Palma, steam now clearly visible atop exact ridge of unstable landmass. There you can see the two white dots on the hillside where the crack is. I will leave the link below for you to go through, because I'm not going to go through the whole thing word for word. I'll just pick out a few sentences. Very serious development on the island of La Palma off the northwest coast of Africa. Sunday afternoon, at least 2 small steam emissions have begun coming out of the ground high up along the ridge atop the unstable landmass on the southwest flank of the island. Steam has been visually verified and confirmed by a geologist. No buildings, no roads on which a vehicle could travel up on the ridge. So there's nothing there that maybe could reflect light and be mistaken for steam. A third vent has opened up lower on the ridge, and in addition to steam being initially visible, the red glow of lava is now also visible. This is about the single worst development that could have taken place in this ongoing eruption. The southwest flank is about 12 miles long, and it's only about 2 miles wide, measured from east to west, and the angle of that land is extremely steep. On the east, the ridge is 6,000 feet tall, that's 2 kilometres. On the west, the land is at sea level, all within 2 miles. In an earlier eruption in 71, that entire ridge, a landmass the size of Manhattan Island in New York City, began to slide towards the ocean. It slid 13 feet, then stopped. The slide created a large crevice along the top of the ridge that was so wide and so deep humans could walk in it, as shown in the photo of the actual crack atop the ridge. You probably already know about this anyway. The crack in the land runs at least 9 miles north to south along the ridge. This is a good diagram that shows the process of how these gigantic volcanic landslides occur, because it's an old volcano. There's the old lava tubes, and it's volcanic rock. It's impermeable to water. So the rainwater collects in the old vents, and it's got nowhere to go. And the vertical. So when new fresh lava comes in, it heats up all the groundwater which is collected inside, turns it to steam. It expands, and just the rest of the land just slides away. And here's an aerial photograph of where all the old lava tubes are located. So this is the billions of tons of rock and earth that could splash into the sea. We're talking upwards of 500 billion tonnes of ash, rock and dirt. That could cause the mega tsunami. When the tsunami reaches the coast of North America, it will pile up on itself and become a wall of water 30 to 50 metres high, a wave 100 to 164 feet tall. Oh dear. Now I've skipped out quite a bit because I think most of us are aware and up on what happened with the tsunami and all that. I want to get to his 8:47 p.m. update on the 31st of October. And he says, more information has come in from a geologist working with a government, and he won't say which government. This geologist pointed out that today the island of La Palma suffered another magnitude 5 earthquake. In and of itself, that does not seem odd, except for this. Yesterday, for the first time in 50 years, La Palma had a magnitude 5 earthquake. First time in 50 years. Strongest quake in 50 years. Here we are, a mere 24 hours later, and La Palma had another magnitude 5 quake. The geologist said that it took weeks for enough magma to move in order that La Palma could have the 5.0 quake yesterday. He pointed out that now, only 24 hours later, enough magma has already moved to give the island yet another 5.0 quake. While the geologist admits this could just be coincidental, he also pointed out that the rush of magma from deep within the earth could now be so voluminous underground that it was magma which caused the second 5.0 quake today. And if that much magma is now moving, he says, and he qualifies this as a highly unlikely possibility, the amount of magma on the move could cause the island of La Palma to actually explode within 48 hours. The geologist points to the public earthquake location data to reiterate his thinking. The public data shows the earthquakes and their depths as follows. And there's the latest, the plot, as it were, on the 31st of October. And it does look as though the magma is moving towards the surface with time. So where you can see here has actually joined the dots and extended the line to come up with the forecast of when it would hit the surface, a time period of 48 hours. But magma and lava doesn't work like that. It doesn't just come up with at a steady rate. It'll come up in pulses, gradually getting nearer at the surface with each pulse. But it is looking likely that quite a large amount of magma is still coming up to the surface and yet to appear. Finally, he pointed out that the Canary Islands government volcano website, and this is important as to what I'm about to show you shortly from today, that the website is showing harmonic tremors, which he says is caused by magma movements higher tonight than at any time in the last 6 weeks, which he says shows a gigantic burst of magma is heading toward the surface. And here is the harmonic tremor chart he referred me to. This is showing all the accumulated earthquakes since the beginning of the eruption. That article blog was on the 31st of October and he gave a 48-hour warning. So we're well past the 48 hours now, but I don't think we're out of the woods yet. Now, the geologist was talking about the two 5.0 magnitude earthquakes that he's very concerned about. And this is where the first one occurred 5 days ago, and it was over to the east where the second one occurred 3 days ago. It was not much more than 24 hours. I think one was late at night and one was early in the morning. It was not less than 2 days apart anyway, and that was 3 days ago. But another one has struck, also magnitude 5.0, 17 hours ago, November the 3rd, 7:27 AM GMT. And that one is also right on the ridge. Now it does say it's at 35 kilometres, 22 mile depth, so it isn't a big wodgy magma just below the surface about to break through, but it is an indication that the volcano is getting fed with a lot more fresh material, fresh fuel to keep going for quite some time yet. This is showing the earthquakes for the last 3 days, and it clearly defines the pool of magma 10 to 15 kilometres below the surface. It's sort of elongated east to west. There's if the magma is on the move, then it looks like it's this red square here is a recent earthquake in the last 12 hours, magnitude 1.5 to 2.7. So is this where the magma's going to move as it rises to the surface rather than going up to the volcano? Is a new vent being created here, and this is this area here near the coast where the banana plantations are. So we'll have to wait and see if a new eruption occurs at the surface, especially if this is getting fed by even more magma. This is from a few days ago, showing recent ground deformation, and you can see along the fault, the ridge from the Cumbre Vieja volcano all the way down, just how much land deformation there's been. Also showing a lot of deformation around the ancient caldera to the north. Now this was from earlier on today, from the live La Palma volcano eruption multi-view, and I watched this quite a lot, and this is at 5:50 PM UK time this afternoon, and I just want you to watch the bottom seismo. We've just had the normal quakes all day, but 10 to 6 this evening the bottom one starts doing this. And I'm going to speed it up a bit. So I'll just it's still going there. Look at the pattern there. They look like harmonic tremors to me. go a bit further. That's still going. Skip a bit further. And a bit too far though. And there we are. And it ended round about can't tell. Let's just play it. That's about 2 minutes in. The whole thing's about 4 minutes long, so that's it ended at about 6:13. So that was about, I don't know, how long was that? I reckon that was that went on continuously for about 23 minutes. If you look at the name, the area where the seismograph covers, it's the Taburi Ente. So the area of the island of La Palma that vibrated with harmonic tremors earlier today for 23 minutes continuously just happens to be the enormous ancient caldera on the north of the island. So I really hope that's not springing back to life. Oh, we're all in big trouble. Here's a picture from Zoom Earth that I snapshotted yesterday, showing the extent of the thick black brown ash cloud covering the whole of the island and much further afar. That YouTube channel I watch, the Multiview, it reports every single small earthquake on La Palma, like minutes after it happens, and also reports larger earthquakes worldwide, like just after a few minutes after it occurred. It's great if you want to follow, if you're interested in earthquakes worldwide. But while I was watching it earlier today, it reported another small earthquake in the vicinity of La Palma. It was only at magnitude 2. I think it was only a 2.0. I could be mistaken. It might have been slightly higher, but you won't see it recorded or in the stats because it was only a 2. But it said it was the location was La Gomera, and that is this island here. So not only is La Palma getting it with earthquakes, but also its neighbouring islands too. So this could be much bigger than what we think. Seismic and volcanic activity seems to be on the rise all over the planet at the moment. All this recent solar activity is going to add to the mix too. As at time of recording, there's a KP index of 7. So we might get some pretty lights in the sky next night or two. I can't see nothing here. My old favourite, Lombok, which I warned about in many of my early videos. I've not forgotten about it, and it seems to be the epicentre of recent quakes during the last few weeks. This is the last month of activity around Lombok. Lombok right in the very centre of it, and we've got there's a 4.9 and a 5.1. So it wouldn't surprise me if one of the most dangerous volcanoes on the planet, Mount Rinjani, exploded into life as well. I had all this prepared for you as well earlier. That bloody bush baby beat me to it. He showed it on his video. Here's another look at it from earlier on this evening. You've got to admit, that is fucking awesome lightning. I'm going to end this video with my latest out-the-box thinking about the universe. But before then, we're going to have a quick look at the weather. Before I get into that, I'd just like to say that I'm watching La Palma, and the Taburiente seismo has been switched off. So they're either doing repairs or there's something more going on that they don't want us to see. Right, here we are at the National Hurricane Centre, the NHC. And we're going to look at Storm Wanda. Wanda started off life as a thunderstorm over Florida on the 25th of October, and since then it's moved out into the Atlantic, up the east coast, done a loop-the-loop, and tracked eastwards into the mid-Atlantic. They kept forecasting it to dissipate, but it's maintained 50-mile-per-hour winds. And it just keeps going. It shouldn't be there now. And it just keeps going. Where's it going? Well, blow me down. This wasn't expected to get anywhere near the UK. But it keeps surpassing expectations. So, by 6 PM Monday, will it surpass its expectations of what it's going to be then? We'll have to wait and see. Looking at the tropical storm force wind speed probabilities for 5 days. We could be in for a really good October storm. Looking at the 50 knot wind speed probabilities, it looks like they're expecting it to, lose a bit of its oomph and then pick up strength again as it approaches Britain. They've even given it a 10 to 20% chance of attaining hurricane status. Bloody hell. This is the very latest, at time of recording, satellite pictures. And it looks like a bloody hurricane now. I'd just like to show you the GFS model for the total accumulated precipitation for the next 16 days in the Pacific Northwest. I'll just let it run through. See the scale on
magnitude 3. Already 2-time updates so far. Spain with depth 12 kilometers occurs an invalid date.
See the scale on the right there, well into the yellows, in excess of 24 inches, 2 feet of rain. But of course it's not going to be rain. There's storm after storm after storm going to be barreling in. So when we look at the same forecast, but looking at expected snowfall in inches, it's showing that parts of British Columbia can expect 158 inches in the next 16 days. That's about 13 foot of snow. We're lucky if we get a couple of inches of snow all bloody winter here where I am. They're going to get nearly a foot per day. Jeez! Now it's time for the moment you've all been waiting for. My new theory on the universe and how it came into being and how it may possibly go into the future. In the past, I've discussed other theories of mine covering the universe, but this one's just a little bit different. Now this is going to be very difficult for me to convey what is in my head into this broadcast. But I'm going to try my very best for you to understand what I'm thinking. What if the speed of light is not a constant at all, but changes with the evolution of the universe? From Einstein's famous equation, energy equals mass times the speed of light squared, we know that the speed of light is directly proportional to the amount of energy in a system and is indirectly proportional to the amount of mass in a system. And I want you to imagine the whole universe as one system. Come along with me now to the beginning of the universe. The moment of creation, where a finite or maybe infinite amount of energy was introduced into a void. It would have been pure energy, no mass. So what does that mean for Einstein's equation? It means the speed of light at the beginning could have been infinite. So I disagree with the inflation theory of the universe. I believe that the whole universe just appeared out of thin nothingness. In an instant, the whole universe came into being. A universe of pure energy. And then the Higgs field came into effect, giving everything mass. And the speed of light was stopped in its tracks, slowed to an absolute crawl. ever since the very creation of matter, or mass, in the universe, that amount has been decreasing, either in the very heart of stars or in the infinite depths of a black hole. The amount of mass in the universe is decreasing. And so, according to Einstein's equation, the speed of light is not a constant, but it gets faster as time goes by. So now I have to question, is the universe really expanding? Or has it been contracting ever since that very first moment? Have we been in the big crunch ever since the very beginning? Over billions of years, if the speed of light is not a constant but has been getting faster and faster, would that be responsible?
In this video,
would that be responsible for the light waves to be stretched out, given the redshift, which gives the impression that galaxies are racing away from us, when in fact the speed of light has changed over eons. We know that light travels slower through a transparent material, i.e. a concentrated mass, than it does through a vacuum. So why not apply the same thinking to the entire universe as a confined system undergoing a repeating, never-ending cosmic crunch? Ah well, this has been Nostradamus. I'm totally off my rocker, and I will say goodbye for now to everyone. Peace and love. Love you all. Goodbye.